Here we are, section 2.4, Newton's third law of motion. How exciting. You get to find out what happens in Newton's third law. Probably already know, but for every action, there is an equal and opposite reaction. That's Newton's third law. For these girls walking on the sidewalk, for every step they take, they're exerting a force down on the sidewalk. The sidewalk is exerting an equal and opposite force on their foot. Examples, we'll give lots and lots of examples here. We have the book on the table. Well, the force due to gravity, or the weight of the book, is down. We have an equal and opposite force, and that would be the force that the table exerts up. Because the forces are balanced, there is no net movement of this object. How about the force of the finger on the wall here, and the force of the wall on the finger? Those are equal and opposite, and because of that, they're balanced. There is no net movement. Here we have a situation you've probably thought about before, maybe not. We have this as the action. The action is the person stepping off the boat. This person's foot is pushing against the boat, that direction. The boat, depending on which force is greater, is the force of the foot pushing against the boat greater, or is the force of the boat pushing against the foot greater? So we have this person exhibiting an action, and their action is actually, the force is pushing this way. The boat, the force of the boat would be to be pushing this way. And because of friction, that boat doesn't really have the ability to push this way very much. It's actually going through the water. So depending on which force is greater, if the force of the person's foot pushing on the boat is greater than the force of the boat being able to push back against the foot, then this boat will move this way, and that person will fall in the water. If the force of the boat pushing back is greater than the force of the person's foot pushing against the boat, then that person, the boat will not move back. The person may jump off, but the boat will not move back away from them. Likely, even a pretty large boat, because of that lack of friction, because they're in the water, that boat will likely move this way. Here's another example of action and reaction. This man is hunting with a hunting rifle, and the action of that bullet exiting that rifle at a very high velocity with very high acceleration. Even though the mass is fairly small, the acceleration is extremely high, so we have a very great amount of force going this way. The reaction this way will be the same amount of force. The gun probably weighs a little bit more than that bullet, but there is going to be a huge amount of force pushing back this way, and that's why you feel that if you've ever shot a rifle, you feel that kick in your shoulder, because it's the equal and opposite reaction. It's the force back against your shoulder from the force of the bullet traveling at a high acceleration the other direction. Now here we have a little scenario. You can try this with your friend at home. It isn't dangerous. Let's say two people have their hands pushed up against each other like this, and they are exerting equal amounts of force. They're standing there, they have their tennis shoes on, standing on the ground, exerting equal amounts of force, this direction and this direction. Well, they should be balanced, right? We should have no net movement. Other forces at work here, obviously, would be, we have the force of gravity going this way. We have the force of the floor holding them up. So those are some other forces at work. What if, however, person 1 were wearing rollerblades? How does that change this picture? You can pause the video for just a minute and think about it. What would happen? If you thought in your head or wrote down in your notes that it's the force of friction, then you're correct. This person, even though they're the same forces that they are exerting on one another, this person lacks the force of friction that would hold him in place. This person has that force of friction, and therefore you will probably see this person slide his feet sliding this way and falling perhaps on his face if he were to take that to the final conclusion of what would go on here. Let's take the scenario of a truck driving down the road and a bug smacking into his windshield. Who experiences a greater force? Well, they both experience the same size of force. The magnitude of the force is the same. It's obviously in opposite directions. The bug is traveling this way and the truck traveling the opposite direction. But they are experiencing the same amount of force. Obviously, their mass and their accelerations are different. But the amount of force they both experience are the same. An advanced idea. How do squids and octopuses use Newton's third law for locomotion? It's kind of an interesting fun fact. Or any other great questions you can come up with. Find the answers and bring them into class and show me what you know. Look forward to seeing you.